All right, so this is graphing our derivative function, our second derivative of f of x given given the original function f of x. So this is our redo, our second time around here. So we're going to be looking at the characteristics of our original function, characteristics of our derivative, and characteristics of our second derivative. Let's zoom in a bit here. All right. So first up, we're going to identify our critical points and our inflection points. So critical points occur where our slope is 0 on our original graph. So our critical points are at 0, 2, and 4. So at 0, my derivative equals 0 because it's a critical point. At 2, my derivative equals 0. Because remember, my derivative function is just my slope of my original function. Then we need to look for our inflection points where we change concavity. So we're concave down until 1. So our first inflection point is 1. There we switch to concave up, and we're concave up until 3. And then we switch to concave down. So we've got 2 inflection points here. One's at 1, and one's at 3. So let's look at increasing and decreasing. Until we get to 0, our first critical point, we are going up. So we are increasing. That would mean if I'm looking at my derivative graph, right, I have positive to the right of 0. Then between 0 and 2, we are decreasing. So between 0 and 2 on my first derivative graph, I am decreasing. Between 2 and 4, we're going back up, so we're increasing, which means on my derivative graph, I am positive. And then on the right side of 4, we are decreasing, which means on my derivative graph, I am negative. Now let's look at concave up and down. We are concave down to the left of 1. And remember, concave down means that I'm looking at the left of 1, right? That would be negative for my second derivative. And then it tells me about the slope of my first derivative graph. So that means my slope, my graph is going to be decreasing, because the second derivative is the rate of change in the first derivative. It's the slope of our of our first derivative graph. So it's a key characteristic we had written down in the notes for the first problem. So from 1 to 3, we are concave up, which means we've got a positive second derivative. Right. Oh, I wrote that below. I guess I'll write this below. And that means we are increasing on our first derivative graph. Lastly, we've got concave down on our original graph from 3 to infinity. So we've got decreasing because that would mean our second derivative is negative. We're ready to make those graphs now. So we need to make sure that we've got our characteristics on here. So our where f prime equals 0, we are going to have x-intercepts. And where f double prime equals 0, we're going to have critical points. Right? So this is on our f prime graph. So let's go ahead and put those on first. So I've got my first derivative equals 0 at 0, 2, and 4. So those are my x-intercepts. And then my critical points, I have at 1 and at 3. We'll decide on their location momentarily. So first, let's plot our f primes. So we know to the left of 0 we're going to have positive, so we're going to have something up here. We know to the right of 0 we're going to have negative, and at 2 we're going to change to positive. I'm looking at the values of my first derivative, so these top ones here. Now we need to think about our critical points where the second derivative equals 0. So those are going to end up being our maxes and mins. The second derivative equals 0 at 1 and at 3. So now that we have graphed our characteristics of f prime and our critical points, right, we're all good in the hood. So here I used blue for my critical points, which is the points where the second derivative equals 0, and I used pink for my x-intercepts, which is where my first derivative equals 0. This is, of course, the graph of f prime of x, so we're going to label it. Now we're going to look at f double prime. For f double prime, our x-intercepts are going to be where f double prime equals 0. Right, so f double prime equals 0 at 1 and at 3. And then we look at our values here that we've got. So I've got negative, and then positive, and then negative. So that means that to the left of 1, I'm going to be, negative. In between 1 and 3, I'm going to be positive, and then I'm going to be negative again. And there we've got it. So go ahead and try the I do problem.